for today, on to chapter 6. So for today we have in terms of graphing the trig functions and then in terms of solving the trig function. So first off, in terms of the two basic trig functions being sine and cosine, my general equation will be in terms of this. A sine bx minus c plus d or cosine, either. My general equation.
For what again?
My equation of a sine wave or a cosine wave. That's my general equation. Okay? When the equation is in this form, we got that the amplitude, which would be the height of the wave, is given by the absolute value of A. The period, which is how long does it take in order for it to repeat, is given by 2 pi over b. The phase shift which is where does your normal sine wave or cosine wave start, is given by c over b. Right. And then this plus d out at the end. The d term, this d, will either raise or lower the curve. So this is what we saw with the exponential and logarithmics, where we said where at the end you had the plus 4, it took the whole curve and raised it up 4. Minus 4, it dropped it 4. It would be the same thing here. If it's a positive number, it takes a whole sine wave or cosine wave and raises it up that many units. If it's a negative number, it drops it that many units. Right. So you did in terms of graphing the trig functions. So let's first look at our basic sine wave. So if I draw out a unit circle, so a unit circle is a circle where the radius is equal to 1. So that means that this will be the point 1, 0. This is going to be 0, 1. This is going to be negative 1, 0. And then this will be 0, negative 1. Okay? On a unit circle. Okay? Okay? And then if I draw a point on my unit circle, I can make a triangle. The coordinates of that point will be given by x, y. The distance from here to here is given by x. The distance here to here is given by y.
That's x1 underneath x1y, or x comma y.
X comma y as a point. Okay. Okay. So my sine function, sine theta, will be given by y over 1, which of course will just be y. So now if I graph my sine function based on this, well, first off, when we graph these things, we're going to talk about our angles in terms of radians, okay? So in terms of radians then, we got that this was 0, this was pi over 2, this was pi, this was 3 pi over 2, and then of course other way around was 2 pi. Given that sine is given by my y-coordinate, at most, this can take on a value of what? At least, it will take on a value of -1. That's all in terms of this point and that point. Okay? And then we're going to graph it. So we got pi over 2, we got pi, we got 3 pi over 2, and then we have 2 pi. Right? Well, given that sine is given by the y-coordinate, what's the y-coordinate at that point? 0. So there's my first point. What's the y-coordinate at this point? 1. So there's my second point. What's the y-coordinate over here? 0. What's the y-coordinate at 3 pi over 2? -1. And then what's the y-coordinate at 2 pi? 0. So we got our 5 points, and that's really all I need in order to graph this. So all we do now is we take and we draw a curve and connect the dots. So I draw a curve. And so my graph of my sine wave is going to look like that. Okay. So to graph these, for sine and cosine, we're going to find those 5 points. Once I know where those are, I can draw a curve and connect the dots. So you want to make sure you draw a curve. Don't draw straight lines. It's not straight lines. Okay? It's not going to be 2 triangles, one pointing up, one pointing down. It's a curve. Right? That's my basic sine wave. But in regards to that sine wave, we can change the amplitude, we can change the period, we can change the starting position in terms of the phase shift. Right? So we get in terms of my general equation, which I had up before. But so now let's say I have something that looks like this. Y equals 3 sine. Oh, let's take it. Maybe. No. All right. We'll go down a little bit. All right. I'm going to do this one, okay? And this is going to be similar like you see on that handout I gave you for the homework. In that I want to know the amplitude, the period, the phase shift, and the graph. It'll also be similar to what you'll see in terms of next week's test. So first off, what is the amplitude?
Absolute value of 3.
So the amplitude will be 3, right? It's the absolute value of A, and A is 3, right? So the absolute value of 3 is 3. Right?
So if it was like a -3, then
It's still 3, yes.
Okay.
Right? What is the period?
2. X.
Pi.
What?
Pi.
Pi is correct. And after all, you got in your notes that the period is given by 2 pi over b. B is the number in front of the x term, right? So this will be 2 pi over 2, which will simplify to just be pi.
What does the period do again?
tells you how long it takes to repeat. Right? Next thing is the phase shift. The phase shift is going to be pi over 2 divided by 2. But that's just a lovely compound fraction, which you all know how to simplify. Right, Abe? Simplify.
Get rid of the 2's, don't you?
Not quite that easy. Okay? So, what does that become? Well, what does it mean? It means pi over 2 divided by 2, right? That's what that means. Which is the same thing as saying 2 over 1, right? How do we divide fractions? We leave the first one the way it was, change the sign to multiplication, and flip the other one over, so we end up at pi over 4. Right? So that's the phase shift. That basically tells you where your normal sine wave starts. So we know the amplitude, we know the period, we know the phase shift. The next thing we want to do is draw the graph that matches this information.
You said phase shift is where it starts?
Yep, where the normal sine wave starts. Right? So let's draw up an axis here. So let's see, we want to do this, we're going to go this way. Amplitude is 3. So let's call that 3, and then let's call that negative 3. Right. Phase shift is pi over 4. So let's call this pi over 4. Right? Now, the period. What I want to know is, where is the ending point of the first cycle? Because after all, sine wave goes on forever and ever in both directions. So to get the end point of my first cycle, we're going to take the phase shift and add the period. So we got pi over 4 plus pi. Well, in order to add fractions, we need to have a common denominator, which will be what? 4. So pi is the same thing as saying 4 pi over 4. So pi over 4 plus 4 pi over 4 takes us to what? Without the toy, because you don't need it. What's 1 pi over 4 plus 4 pi over 4? It is 5 pi over 4. After all, it was not a tricky question. Okay? So my end point of the first cycle,
I don't understand how you got there, though. Okay.
I added.
I know, but why?
Because how do we add fractions? We have a common denominator.
That's not what I'm asking. Why did you take the phase shift and not the period? Getting this one.
Okay? Because the period tells you how long it takes to repeat. Right? That's what the period gives you, is how long it takes to repeat. So once I graph, so basically whatever this is going to repeat every that many units, right? That's what period is. How long it takes to repeat. So that gives me the end point of the first cycle.
The end point, gotcha.
Okay? All right. Now I want to graph this. And again, all I need is 5 points to do this. Okay? I got the start point, I got the end point. The other point I need for reference is I do need about that point right there, which is the midpoint. So we'll put a mark in there. Sine wave starts at 0. In the middle it's 0. At the end it's 0. So this point, that point. That's what a sine wave does. It starts at 0, in the middle it's 0, at the end it's 0. halfway in between the first two, it reaches the max. Halfway in between these two, it reaches the min. Okay?
It reaches the what?
Minimum. Okay? Well, we got our 5 points. The next thing we do is we connect the dots.
Minimum being +3 and -3?
Well, the maximum is +3.
Right.
The minimum is -3, right? So now we connect the dots, right? So now this is where one of those things you may have had when you were a kid come in handy. You may have one of those books where you had next to the dots, you had the little numbers. And you took your pen or pencil and you eventually went around from dot to dot and you connected the dots from 1 to 2 to 3 to 4 to 5, and we get our graph of our sine wave. And that curve will go on forever and ever in both directions. Okay? So again, the amplitude is given by the number in front. Amplitude is always a positive number. Okay. The period is given by 2 pi over b, which basically is how long does it take for the curve to repeat. And then the phase shift is given by c over b, which basically tells you the starting point of your normal sine or cosine curve. Right? Right? So, for example, if I had something like this, y equals -2 sine again, but that will be a pi over 3x depending on how well this dot matrix works out. Yeah, a little better maybe. Okay? Alright. So we got that. And again, we want to know amplitude, period, phase shift, graph. First off, what's the amplitude? 2, right? And again, amplitude will always be a positive number. How about the period? So first off, what will I get in terms of the math part?
2 pi over 2?
It'll be 2 pi over pi over 3, right?
Yeah, 2 pi over 3. Yeah.
So it's going to be 2 pi over pi over 3. Again, what does that mean? It means 2 pi divided by pi over 3. Right? Well, you leave the first one the way it was, change the sign to multiplication, flip the other one over, and what do we end up at? 6. Exactly 6. Because after all, the pi's go away. Pi on top, pi on the bottom, they cancel. Alright? Next thing is the phase shift. What's the phase shift going to be?
Pi over 3 over pi over 3.
Okay.
Or
What?
6.
Okay? No, it's given by c over b, right?
Yeah.
And in this case, it's actually going to be a negative pi over 3 over pi over 3.
Why negative?
Because you go back to how my original equation was defined. It was bx minus c.
Oh,
So in order to be a plus, meant that c itself had to have been a negative. Okay? All right. So what is negative pi over 3 divided by pi over 3? What does that become? No.
-1.
What?
-1.
Negative 1 is correct. Alright? Okay. Alright, now, we're going to graph it. Okay. Phase shift is -1, so let's call that -1. Right? We said the amplitude was 2. So let's call this 2, and let's call that -2. To get the endpoint of the first cycle,
Phase shift plus the period.
phase shift plus the period. So -1 plus 6 takes us to what? 5. Right? So let's call that 5. Right? And again, for reference, I do need the midpoint, so let's call this the midpoint. Right? And again, it's a sine wave, which means it starts at 0, in the middle it's 0, and at the end it's 0. So let's plot those 3 points first. Right? But now, something happens with this sine wave, because what was the number actually out front? It was -2. What is a -2 going to do to my sine curve? It flips it.
So if it's a negative,
It flips the curve over. Right? So I mean, now this is where the negative comes into play. It's going to take your sine curve and it flips it. So instead of going up first, it's going to go down first. And then over here will be the max. Right? So a negative out front will take the curve and it flips it around. Okay? So sine wave looks like that. Yes.
how did you get the -1 for the phase shift?
Negative pi over 3 divided by positive pi over 3.
And then
Let's do this. What's -2 divided by 2?
-1.
What's -5 divided by 5?
-1.
Okay. What's -200 divided
but it's
by
negative pi.
over 3? Divided by pi over 3. Same number on top and bottom, just one's positive, one's negative. It's no different than -5 divided by 5. Really. Okay? Right? It's only pi. Alright. Right? Sine waves. Right? Now, how about given something like this? Now I tell you, I want the equation of my, in this form, maybe. Okay. And now I tell you that the amplitude is 5. The period is 4, and the phase shift is 1. I want the equation that would go with that information, and we're going to assume it's a positive sine wave. This one. All right. So, what's the value of A going to be?
5.
5. So let's write that in first. So we know it's going to be y equals 5 sine. Okay. We got that part. Now the period we said is given by 2 pi over b. So we have that 4 is going to equal 2 pi over b. So we want to solve that equation for b. Well, what's the opposite of dividing? Multiplying. So we get 4b is going to equal 2 pi. And then what's the opposite of multiplying? Dividing. So we divide by 4. And so B is going to be what?
2 pi over 4.
And we can simplify that.
1 pi over 2.
Pi over 2, right?
I said 1 pi.
Right? So we now know, in terms of my equation, that this will now be pi over 2x. Right? Now we need to know C. Well, the phase shift is given by C over B. So we got 1 is going to equal C over pi over 2. So that's what our B was. Well, what's the opposite of multiplying? What's the opposite of dividing? Multiplying. So what is 1 times the pi over 2? What's 1 times pi over 2?
Pi over 2.
Right. Again, it wasn't a tricky question, right? Right? And so we know that C is pi over 2. And so my equation will be that. So that is the equation that goes with that information.
You can go down to C again. See that.
So the other basic trig function then is cosine. And in terms of a cosine curve, the basic cosine curve is given by the x-coordinate. And so, just going through this, you go back to my graph of the unit circle. On the x-coordinate, we said the biggest that it got was +1. The smallest that it got was -1. So cosine goes between 1 and -1. And then we're going to have pi over 2, and pi, 3 pi over 2, and then, and if you work your way around the unit circle, you got, it's 1 there. At pi over 2, the x is 0. At pi, the x-coordinate was -1. At 3 pi over 2, we are back to 0. And then at 2 pi, we're back to 1. And again, we get our 5 dots, which is all we need. And then we connect the dots. Right? Something like that. Without the dashes. And that's our cosine curve. So cosine and sine wave are really just are out of phase by 90 degrees or pi over 2. So again, you guys now given a cosine question, same basic equation, the a sine bx minus c, whether it's sine or cosine makes no difference. But if we had something like this, y equals 4 cosine maybe it's 5. Yeah, better. Y equals 4 cosine. That's 3 pi over 4. With all the dots. Okay? So first off, what's the amplitude?
4.
4. All right. Amplitude is 4. Period will first be given by 2 pi divided by 1/4, which will simplify to what? Any takers?
8 pi.
8 pi is correct. After all, that's 2 pi divided by 1/4, which will become 2 pi times 4 when you do it, right? And then lastly, the phase shift. The phase shift here is going to be negative 3 pi over 4 divided by 1/4. And again,
Why is it negative?
again, because of the way the original equation is defined, bx minus c, in order for that to be a positive number, meant that c itself had to have been a negative number. Okay? All right. What does that simplify to? The other big question. Huh?
4 pi.
No.
Negative 3 pi.
Negative 3 pi is correct.
Be my friend.
Again, how does it work? It's negative 3 pi over 4 divided by 1/4. Okay? So you get negative 3 pi over 4. Change the sign to multiplication. This becomes 4 over 1. The 4's cancel. And we end up at negative 3 pi. Right? Right? So we know the amplitude, we know the period, we know the phase shift. The next thing everybody should be able to do is draw a graph. Right? So let's make an axis. Let's call this negative 3 pi. So a negative 3 pi plus 8 pi is going to take us to 5 pi, right? My amplitude was 4. So we're going to call this 4. We're going to call this negative 4. And then about here is the midpoint for reference. Now this time it's a cosine wave. Okay? So you got to make sure when you're drawing these, you draw the right wave for the right function. Again, a cosine wave is the one that goes like that. So cosine starts at the max. It ends at the max. At the halfway point is where we hit the minimum. Right? So I get those 3 dots. Halfway in between these two, I cross the axis. Halfway in between those two, I cross the axis. I have my 5 dots. The next thing, connect the dots. And we get our cosine curve. Okay. So sine waves, cosine waves. Well, that's 2. 4 more to go. After all, there's 6 trig functions.
How do you define, so I'm gonna miss this, how do you define what points are on your exact, on your X?
What?
How do you define the, like the -3 and like the positive?
Well, the -3 came from the phase shift. That's my starting point.
Okay.
And the endpoint, again, we say you take the phase shift plus the period, gives you the endpoint of that first cycle.
Okay.
And then again, it will go on forever and ever in both directions. Okay? All right. So, which trig function is the reciprocal of sine? What?
Secant?
No, not secant.
Sine -1.
Cosecant. Sine and cosecant are reciprocals of each other. So, pi over 2, pi, 3 pi over 2, 2 pi. Call that 1, call that -1. Let's draw my sine wave. There, 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 up here, and then down here. My basic sine wave looks like that. That's my basic sine curve. Now we're going to draw the cosecant curve. Sine and cosecant are reciprocals of each other. So my blue graph is going to be y equals cosecant of that. Well, let's start here. What's the reciprocal of 1? It's 1, right? 1 over 1. Okay? What is 1 divided by 0?
Can't.
You can't. It's undefined. So, we're going to get an asymptote line there. We're going to get another one here. We're going to get another one here. So cosecant is undefined at 0, pi, 2 pi, 3 pi, 5 pi, negative pi, negative 2 pi, and so on. Okay? Now, what happens in between? Well, again, it's a reciprocal. As I go this way down my red curve, the value here is getting smaller and smaller and smaller, right? What's 1 divided by a smaller and smaller decimal number going to become? Well, what's 1 divided by 0.5?
0.5.
What's 1 divided by 0.5? 2. What's 1 divided by 0.1? 10. So as what happens here then my curve is this is getting larger and larger, and then we get the same thing down here. I get a U shape down there. So one way of graphing a cosecant graph, for one method, is to first draw the corresponding sine wave. Once you know the sine wave, cosecant graph is easy. So, for example, let's say I wanted to graph y equals 2 cosecant 2x, maybe. 2 cosecant 2x minus pi over 2. Well, to do this, I want to first think about this in terms of my sine wave. The amplitude will be 2. The period is going to be 2 pi over 2, which will be pi. And then my phase shift is going to be pi over 2 divided by 2, which will be pi over 4. Right? So if I graph this first, this is going to be pi over 4. I think we had this up earlier. But pi over 4 plus pi will give me 5 pi over 4. We had one like that earlier. Okay. Amplitude is 2. So let's call that 2. Let's call that negative 2. We'll put this marking for reference. And if I graph my sine wave, which I'll do in red, we're going to have here, here, and here. Halfway in between these two, we reach the max. Halfway between the other two, we reach the min. And my sine wave, maybe, will look something like that, except for this will be filled in on your paper and not on my graph. And then, to draw my cosecant, which is what I want, that's easy. Everywhere it crosses the axis, we put in asymptote lines. We put a U shape here, and we put a U shape down there, and we have our graph.
Those lines are called asymptote?
Asymptotes. Asymptotes. Those are those lines. Okay? Right. Now the same thing works with cosine and secant. We can do the same deal. Okay? So again, if I draw my basic cosine graph, which we 1, -1. So cosine graph, we have here, it's here, down here, back to 0, and then back up to +1. So my cosine graph was the one that looked like this. So this is y equals cosine. Right? So my secant graph, again, it's reciprocal. And again, everywhere where it cuts the axis would be the asymptote line. And so we would get a U shape up here. There'd be another one down there. And then there would be another one over here. And this would be y equals cosecant x. And again, one way of graphing a cosecant graph is to first graph the corresponding cosine wave, put in the asymptote line, and then all you got to do is draw a bunch of U's. Now, of course, for some of you, you do have graphing calculators. And if you actually know how to use your graphing calculator, one of the things graphing calculators can do, they can graph. Hence the name, right? Providing you actually know how to use it. But these can be done on a graphing calculator. Right, Abe?
Yes, sir.
You know how to do it?
Go to y equals.
Okay. That's a good start, right?
Yeah.
All right. All right, so that's sine, cosine, secant, cosecant. That leaves tangent and cotangent. Were the other two ones that are left in terms of graphing. Tricky. All right, tangent and cotangent. Now, let's go back, draw my unit circle. again, this is 1, 0. This is going to be 0, 1. This would be -1, 0. And then this is going to be 0, -1. Okay. Again, if I draw a triangle where this is some point on the circle, and I can make a triangle like this, the number from here to here is given by x. From here to here is given by the y-coordinate. Again, that number is 1, given it to you in the circle. But given this triangle, as we saw before when we had up where I did the trig function in terms of x's and y's and r's, we got that tangent is going to be given by y over x. Okay? Yep. If I look at what I know so far in regards to my points, we got pi over 2, pi, 3 pi over 2, and then, okay? So first off, we start here at this point. This is going to be 0 over 1. Well, 0 divided by 1 is going to be 0. So we got a point there. I go to this point. This will be 1 divided by 0, but that's going to be undefined. Right, so we get that. I go over here. We got 0 divided by -1. That's going to be 0. So I got a point there. I go down here. We got -1 divided by 0. Well, that's undefined. And then 2 pi, we're back to 0. So far, we don't know much about my graph. Right? I know when it's 0, and I know when it's undefined. That's it. Well, what happens when I start to go this way around my curve? Well, if I start to go this way, the y variable is small, but the x number is large, right? So a small number divided by a large number gives you a small number. Okay? And so in terms of my curve, for my tangent function, you're going to get curves that look like this. So once I cross over into the second quadrant, we got that y is positive, x is negative, which is now we start from negative infinity. We go up to 0, and then we go off to positive infinity. We cross the barrier again. Again, we're down to negative. Right? And so tangent is undefined at pi over 2, 3 pi over 2, negative pi over 2. So, right. So in regards to drawing a tangent curve, right, we can have in terms of my general tangent function, which will be in terms of this. Tangent really doesn't have an amplitude because after all it goes off to infinity. The same with cosecant and secant. They don't have an amplitude. They go to infinity. Right? But for these ones, all I need to know in order to draw my tangent graph, I need to know where these are. Once I know where those are, drawing the tangent graph is easy. So that's what we figure out. So to draw a tangent graph, we just take this part in parentheses, And we set this equal to pi over 2. And we set this equal to negative pi over 2, which are the two closest asymptotes from the origin. Okay. Those are the two closest. So, for example, then, if I have y equals 3 tangent, let's see, 2x minus 1. So what I do is take the part in parentheses, set it equal to pi over 2, and set it equal to negative pi over 2. And we want to take those two equations and solve each one of those for x. Well, what's the opposite of subtracting? Adding. So we're going to add pi. Add pi. Again, in order to add fraction, we need to have a common denominator. So pi, I'm going to rewrite as 2 pi over 2. So we get 2x. Pi over 2 plus a 2 pi over 2 will give us 1 pi over 2 plus 2 pi over 2 gives us 3 pi over 2. Right? Right? What's the opposite of multiplying? Divide.
Where'd that other 2 come from? Where'd this range?
Because I rewrote, in order to add or subtract fractions, I need to have a common denominator. So pi is the same thing as saying 2 pi over 2.
Alright.
Okay? Right? Last step is to divide. So I divide this by 2, I divide this by 2. And if we do that, we get x is going to be 3 pi over 4. Okay? Again, fractions. If you have any fractional impairments, you need to get over them. Okay? We do the same thing on the other side. So here again, we're going to add pi, which again is the same thing as saying 2 pi over 2. So this is going to be 2x. What's a minus pi over 2 plus 2 pi over 2?
Nothing.
No. Minus 1 plus 2 is 1. So this will be pi over 2. Again, we divide by 2. And this time, you get x will be pi over 4. Again, we should be able to go through and figure out how that works. Fracted. So now to graph this, all I do in terms of graphing this tangent wave is we're going to call this pi over 4. Let's call this 3 pi over 4. We'll put this mark in the middle. Basically, these tell you where the asymptote lines are. So we put a line in here. We put a line in there. My tangent curve is going to go like that. Now you can graph tangent on the toy. The only thing about the toy, though, the toy gets weird in terms of the graph because it doesn't know what to do with this point of no return. So you'll see these curves, but you're also going to see a line that goes up and down in the curve. which is where the asymptotes are, but it sort of puts them in the graph. Be graphing on a graphing calculator. I didn't know quite how to handle that. Okay. So that's tangent. The argument is basically the same when you graph cotangent. The only difference is for my cotangent graph, so for y equals cotangent, my graph is going to look pi over 2, pi, and now for cotangent, my asymptotes and my graph runs in the opposite direction for cotangent. So, same basic shape except for it's split in cotangent. Okay. And so in terms of the general one, we got y equals a cotangent bx minus c. And to graph this, again, all we need to do is figure out where are the asymptotes. So what we do now for this one, for cotangent, is we take this part, and we're going to have bx minus c is equal to 0, and bx minus c is equal to pi. Okay. So those are the two closest asymptotes relative to the origin. And again, we just take the equation, solve for x. Find the asymptote lines, draw the curve. So those are the graphs of the 6 trig functions. Okay. So the last section out of there deals with solving a trig function. So you get something like this. Okay? So I want to solve this one. We got 3 sine of 3x is equal to 1.5. Right? We want to solve that. We want to get x. And I want to know, we want to solve for all x where x is a number in between 0 and 360 degrees. Okay. So we want to solve that. X is going to be an angle between 0 and 360. Okay. Well, first off, what's the opposite of multiplying?
Pi.
So we divide by 3. So sine of 3x, what's 1.5 divided by 3? 0.5. Right? But you're fine with that part, right? All right. So that says that the sine of 3x is 0.5. But we want to know the angle. The way you find angles is by using sine minus 1, cosine minus 1, tangent minus 1. So we get that 3x is going to equal the inverse sine of 0.5. Well, what is the inverse sine of 0.5?
30.
30. Okay? Okay. Now, your toy only gives you one answer. Okay? It will only give you answers that are either in the first quadrant or in the fourth quadrant. That's all the toy gives you. But, remember my graph of my sine wave? We got that sine is positive not only in the first quadrant, but also in the second quadrant. So what other angle will sine be 0.5? That's in the second quadrant. So you think about your homework question from just, that was due today. You had that one where you had to go back and forth from first to second quadrant. If the one angle is 30, what's the other angle?
Or 30.
Now the one angle, we already know the one angle is 30.
150?
150 is
Yeah.
correct. So the other possibility is that 3x is 150. Okay? Either one's possible. Okay? Well, let's solve this. Well, this is easy enough. What's the opposite of multiplying? Divide, right? Right? 10. And we can do the same thing here. Divide by 3. Divide by 3. And we get x is 50 degrees. Right? So we got 10 degrees, we got 50 degrees. But I said I want all possibilities. Well, sine repeats every 360 degrees. Right? So we said the first possibility here was 30. What is 30 plus 360? 390. What is 390 divided by 3? 130. So my next angle is 130. Right? Right? Well, if I go around another 360, where am I at? What's 390 plus 360?
420.
Huh?
420?
Well, 390 plus 360 will take me to 750, right? What is 750 divided by 3? $250, okay? So you notice there seems to be a pattern. It went up 120, went up 120, which means if I go around again, I'm past my 360 mark, right? All right. Now we got to do the same thing here. We said this was 150. So what's 150 plus 360? $150 plus 360 is 510. So what is 510 divided by 3? 170. Okay. Right. If I add another 360, I'm up to 870. What is 870 divided by 3? 290, right?
What's the point of these numbers?
Because all of these satisfy my conditions. Given that the angle is in between 0 and 360, so my answers here are going to be 10, 50, 130, 170, 250, and 290.
Oh, so you have to have all of those.
All of those.
No greater than 360.
Right. Again, my condition was that the angle was a number between 0 and 360, okay? Right? Now, you could do this in terms of pi, but it's a lot of work for pi's. People like angles and degrees are easier to deal with than pi. But you could do it in terms of pi either way. But in terms of like on next week's test, I give you one like this. It'll be in terms of degrees to find the possibilities. So again, you got to remember that the wave repeats in terms of sine or cosine. It repeats every 360. You're fast.
So basically that's one cycle that we're,
Again, that fits the conditions here that x was a number between 0 and 360. Right? Right? So, we did that. Graphing. Good thing it's empty.
Yeah.
Right? Yeah, so the ones you have that come from homework, from this section, basically all in degrees, find the answers, okay? All right. Any questions on all that fun stuff? No? You will next week. So there is one last thing for the day.
Bring it on.
All right. So there are 3 questions. One is draw the graph, like we did earlier. The other one is given the amplitude, given the period, given the phase shift, tell me the equation that would match that information. And then the third one is like the one we just did up on the board. Solve for the angle. And again, I want all values in between 0 and 300 and...
we'll just do standard first.
Where were you? There's a change in the homework. Well, that and part of the book. Alright, it's
You gotta get the